Hello friends, welcome to Susan and John MathTube. So we are still on Laplace transform, lesson number 4. And our aim today is to learn how to find the Laplace transform of a little bit complicated hyperbolic functions. And for that, we have to learn a rule that is called Osborne's rule, which will help us every trigonometric formulae or the identity into the hyperbolic equivalent. Anyway, let's start. So, the first thing, the most important thing, and I hope you're doing these things. So, point number 1, are you ready with pen and paper? And point number 2, I hope you're working out all the problems along with me. And here we go with point 3, 4 and 5. And have a quick recap, because without these formulae we cannot do anything. So please make sure you're really good with all the formulae. And I hope you remember the shortcut. I told you if you want sine, remember it will not start with s. Similarly for sin x, I told you there are a few ways to read this. You can read this as sine hyperbolic x or hyperbolic sine x or sin x. This is more common in the mathematical world. You can check it in mathematical dictionaries. I heard some people rarely calling this as chinch x or something also. Okay, anyway, chin x or sin x. Okay, I prefer sin x. Sin, cosh, dan, she, cosec and coth. And same logic here. Since it starts with this, the formula will not start with a. That's a memory aid. There is no logic, to be honest. It's just a memory aid. Remember, there is a connection between sine and sin. There is a connection between the trigonometric function and the hyperbolic equivalent. And this connection you might have learned in your class 11 or 12 when you learned about the hyperbolic function, and that is sine ix equal to I sin x. Or if you want to read sine ix equal to I hyperbolic sine x. But that's a little bit boring. Why do you read this as hyperbolic sine x? Come on, read like a mathematician, sin x. And then we have cos ix is equal to cosh x. And of course, there are only two basic trigonometric functions, because all the other trigonometric functions are derived from sine and cos. So I'm not going to write the other four standard trigonometric functions. Okay, now this actually means, or this actually implies, corresponding to every trigonometric formulae, there will be an hyperbolic equivalent. That is, corresponding to every trigonometric identity, there will be a hyperbolic identity. And the mathematician Osborne, he found a trick. And the trick is actually the property of powers of I. We know that I square is minus 1. And I to the power 4 is 1. And again I to the power 6 is minus 1. I to the power 8 is 1. So it keeps on moving like this. Anyway, I'll tell you the trick. Suppose you want to convert any trigonometric identity into its hyperbolic equivalent. Then what you do first is change the trigonometric function into the hyperbolic function. So what is step number 1? We change the trigonometric function. For example, if you see tan A in the original formula, you write tan A in the hyperbolic equivalent. Okay, point number 2. If you see sine square or something like sine into sine, for example sine A into sine B, then make sure in your new formula you change the sign. That is, if you have plus in the trigonometric formula, make it minus, and if you have minus in the trigonometric formula, make it plus. That's it. You have the hyperbolic equivalent, and this rule is called, or this shortcut is called, Osborne's technique. Okay, I'll give you one example. What is cos square theta plus sine square theta? It's a trigonometric formula, and we know that it's 1. We know this trigonometric identity. Now, to create the hyperbolic equivalent, what you do is you write the same thing, but instead of cos, you use cosh. So, you write the same thing, but don't write plus or minus for the time being. So, you just imitate the above formula in the hyperbolic format. Equal to you can write. Okay, so that is step number 1. See, you have changed sine, cos, tan into the hyperbolic equivalent, sine, cosh, tan, etc. Now, point number 2 tells you, if you see sine square in the original formula or sine into sine effect in the original formula, then I can see sine into sine or sine square. So, here what we do is we change the sign. That's it. You can check this formula. You might have derived this in class 12th. See, so easy. This is a shortcut, and this is called the Osborne's rule. Okay, I'll give you one more example. Suppose we take the trigonometric formula tan 2 theta. Can you tell me what is tan 2 theta? Yeah, 2 tan theta, the whole divided by 1 minus tan square theta. Now I want the hyperbolic equivalent. So what I do is I write tan 2 theta is equal to 2 tan theta, the whole divided by 1 minus tan square theta. By the way, I am not supposed to write this minus. Equal to you can write, divided you can write, plus you should not write, minus you should not write. Okay, now, so step number 1 is done. Now the question is, are you able to see sine square or an implied effect of sine square here? Okay, the answer is yes. What is tan square theta? Isn't it sine square theta by cos square theta? Okay, that means you see minus here, here the answer will be plus. Okay, I'll give you more examples so that it becomes perfect. What is sine 2 theta? Isn't it 2 sine theta cos theta? So if you want the hyperbolic equivalent, what you do is you just write the same formula using the hyperbolic equivalence. So sine 2 theta, 2 sine theta and cosh theta. Now the next question is, are you able to see sine square in an implied manner or in an explicit manner? That means in the last formula you saw that there is no, explicitly we cannot see sine square, but it is hiding inside this tan square. So here, no, there is no sine square or sine into sine effect. No, it's not there. So that's it. The formula will be same. Okay, once more, to make things very clear, I'll write the formula for cos A plus B. So can you tell me what is cos A plus B? Cos A cos B minus sin A sin B. Okay, now I want the hyperbolic equivalent. So I write cosh A plus B. I'll put equal to cosh A cosh B, and I'm going to write sin A sin B. Okay, now I'm going to analyze the question. No, I don't see sine square. Neither do I see sine into sine effect. Here, no. Yeah, I can see that sine into sine. Okay, so this minus becomes plus. I hope now the rule is clear for you. Okay, so let's do 2 or 3 problems related to Laplace. Now you know the hyperbolic trick, or the trick to convert trigonometric formulae into the hyperbolic equivalent. Let's start with a few problems. So write the first question. Find the Laplace transform of cosh square t. Okay, so what you do is you have to remember the trigonometric formula cos square theta. I think we used in the last video. Yeah, this is 1 by 2 into 1 plus cos double the angle. But they did not ask for trigonometric cos square. They are asking for hyperbolic cos. Okay, so I had to use Osborne's trick and write the hyperbolic equivalent. So cos square theta I can write equal to, I can write 1 by 2, I can write 1. No, I should not write plus. Okay, I hope you understood this step. Now I am looking for sine square, or an implied effect, a hidden effect. For example, sine square will be hiding inside sine cube, because sine cube is sine square into sine. Sine square may be hiding inside tan square. Sine square may be hiding inside cosec square. So you have to check whether sine square is hiding somewhere, implicitly or explicitly. Okay, I don't see sine square, I don't see sine square. So it's going to be the same thing here. That's it. Now we are ready for Laplace. So we get Laplace of 1 by 2, 1 plus cosh double the angle, double the argument. Now apply linearity property. So this 1 by 2 goes outside, and we get Laplace of 1 plus cosh 2t. And that will be 1 by 2. I'll put the brackets are very important. Laplace of 1 plus Laplace of cosh 2t. Okay, formula time. So we have the formula list. We want Laplace of 1, and we need Laplace of cosh 80. Okay, that's it. So the answer will be 1 by 2. What is Laplace of 1? 1 by s. And what is Laplace of cosh 2t? S by s square minus 4. Okay, now you can take LCM and simplify. So it becomes 1 by 2 and s times s square minus 4. S square minus 4 plus s square, etc., etc., etc. You can simplify that by yourself. Okay, now another question. Find the Laplace of sine square. Okay, so again hyperbolic. Now no need to worry, you know the trick. Osborne's rule. So we have sine square theta is equal to, come on, tell me, what's the trigonometric formula? Yeah, 1 minus cos double the angle. So now I am going to write the hyperbolic equivalent. So I am going to write like sine square theta is equal to, I am allowed to write 1 by 2, I am allowed to write 1 minus, I am not allowed to write, I will write cosh 2 theta. Okay, now I am searching for, I am going to search for sine square. So what should I do? I see positive here, I have to make negative here. Equal to is okay, 1 by 2 is okay, 1 is okay. No sine square. So write the same thing here. Okay, and that means sine square theta is equal to, I will multiply throughout by minus. So we get 1 by 2 into cosh 2 theta minus 1. I hope you understood that trick. Okay, that's it my friends. Now we are ready. And what is instead of theta here? 2t. I think we'll write that and start. So it will be, we can plug in that value directly. In exam, you can do this inside a box. So sine square 2t. So we have to replace theta with 2t. So we get 1 by 2 cosh, double the angle, minus 1. That's it. So we get this is equal to Laplace of 1 by 2 cosh 4t minus 1. And that will be 1 by 2 Laplace of cosh 4t minus 1. And that will be 1 by 2 Laplace of cosh 4t minus Laplace of 1. Okay, formula time. So I wanted to check the formula for cosh and 1. So that means the answer will be 1 by 2 into cosh. C means it will start with S. So S by S square minus 16 minus 1 by S. Now you can take LCM and simplify, and that's your job. Okay, now let's go for a little bit more complicated problem. Laplace of, please write, find the Laplace of sine cube t. So what should we do first? Yeah, we have to start with the trigonometric equivalent. In the last video, we learned how to find the Laplace of cos cube and sine cube. So what we do is, we always start with sine 3 theta or cos 3 theta according to the question. They will ask you cube, you will start from 3 theta. And the formula is, I hope you remember the formula. What's the formula for sine 3 theta? Think about it. Okay, 3 sine theta minus 4 sine cube theta. Now look at this, we are interested in this. So I am going to take it to the left side. So 4 sine cube theta is equal to 3 sine theta minus sine 3 theta. So sine cube theta is equal to, now I am going to divide throughout by 4. So we get 3 by 4 sine theta minus 1 by 4 sine 3 theta. Now Osborne time. So what does Osborne tell you? Okay, first you write the formula in hyperbolic equivalent. You are allowed to put equal to, you are allowed to write products, but you are not allowed to write, okay, that is the first thing to do. Now what we do is, we scan for sine square in an implicit or an explicit. We should always remember the sine square might be hiding somewhere. And also you should check for sine into sine. For example, sine A into sine B. Okay, now I can see sine square is hiding. Our sine square is hiding here, isn't it? This is sine square into sine. Okay, so that means we have to put negative here. No sine square, no sine square. So write the same thing. That's it. Now I am going to multiply throughout by negative. So I will get sine cube theta is equal to, what happens when you multiply throughout by negative? Yeah, it will get reversed. So 1 by 4 sine 3 theta minus 3 by 4 sine theta. But we don't have theta here, so be careful. So our answer becomes Laplace of this is equal to this. I'll put it in a box. Yeah, 1 by 4 sine 3t minus 3 by 4 sine t. And that will be equal to 1 by 4 into formula time. So you can check the formula for hyperbolic sine? Yeah, A by. Okay, now look at this. The answer will be, it starts with S, so answer will be A by S square minus 9 minus 3 by 4. It starts with S, so 1 by S square minus 1. And that's it. You can take LCM, simplify, take 1 by 4 common, and that will be your job. Now we are ready for the last part of the formula, that is applying t power n. And from the next video, we will be actually doing questions from your past paper, because we are going to apply the important properties of Laplace transform. And that's exactly what we are going to do in the next video. So look at this. We will discuss some small problems related to Laplace of t to the power n. So remember, if n is a positive integer, then the formula is n factorial by s to the power n plus 1. And suppose we have Laplace of t to the power 3. The answer will be 3 factorial by s to the power 3 plus 1, that is 4. Suppose you want Laplace of t to the power 9. Then that will be 9 factorial by s to the power 9 plus 1. Suppose you want Laplace of root t. The formula will not work, because I told you the power should be a positive integer, and this is not a positive integer. So what we do is we go for the second formula, the gamma one. Its symbol gamma n plus 1. So that will be gamma 1 by 2 plus 1. Yeah, 3 by 2. The whole divided by s to the power n plus 1. I think you remember evaluating gamma functions in your first semester whenever we have a fraction with denominator 2. It's very easy. You reduce the whole number by 1. Again you reduce by 1. Again you reduce by 1. It is guaranteed at one point you will reach 1 by 2, because the denominator is 2. And at this point you put root pi. Suppose you have gamma 11 by 2. What is 11 by 2 minus 1? Yeah, 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2. Yeah, and a root pi. So time to solve this problem. That will be 3 by 2 minus 1. 1 by 2 root pi by s to the power 3 by 2. And you can try one more and we can conclude that video. 1 by root t. Okay, and that will be Laplace of t to the power minus 1 by 2. Try it yourself. Okay, so in the next video we are going for the questions they usually ask in exam. In your exam, from the chapter Laplace transform, there will be 3 questions. So 5 marks each. But normally what they do is, in the first question there will be 2 parts, and there will be 2 small questions which will be kind of like connected to the problems which we learned in lesson 3 and 4. Or in other words, if you understood and if you have practiced all the problems properly from lesson 3 and 4, you will be able to get this 5 marks from here with the help of properties which you learn in lesson number 5. So I'll be back soon, and as always, if you like the video, please share with your friends and please like, of course, and we'll meet soon. So till then, bye.